Hello everyone and welcome back to my Tech vs. Magic series. As usual, we're going to go over what I've done between episodes first. I've hooked up the silicon tank and the sodium tank to our liquid transportation system so that now those are properly stored. I've also made a couple of changes to our programming, and I've added sortrons here, down here, full set now, goes 5, 6, 7, 8, 9, 10. Then there is a sortron over there, connected to the compressor, and a sortron here connected to compressed air and sodium sulfide cell chest. Another one here connected to the empty cells chest, which is empty. And you'll note this tube is colored white, as is that one there. That's to prevent the cells from just looping back through the system if we color them and take them out from that. Also, there is now a sortron on top of the sulfur or sodium cells here, and slot 4 because this has a different way it arranges slots. So this is slot 4. It goes top to bottom instead of across and then down like normal chest. That's just to remind me. And this way I can make sure that I have enough sodium to actually make the sodium sulfide, which, given that change, I had to make some changes to the programming for sodium sulfide, as well as added a couple of things. So first off, we'll start down here. I added 2 constant, and I've been using that instead of 2 variable. I had to look up the words I needed to do to figure out how to do this, which is why I didn't do it last time. But first we have create, which is something that takes the name and sets up the name for a word, basically. Both variable and constants use it. So when you're creating a constant, the name that you choose, that's this create part is what does that. Swap will swap the 2 numbers that are going to be on the stack that are going to be used for setting up the constant. Then these 2, a comma is allocates memory and then stores the topmost value on the stack in that memory. So we do that twice to get both values. And then this does thing. This is a little complicated. What we're essentially doing is overriding how the normal word definition works, which is we're breaking it into pieces. So the part from here to here is what the word does when you're compiling it. And the part after the does is what you do when you actually run the word. So when you're compiling it, it takes the numbers off the stack. It creates the name and then takes the numbers off the stack and stores them in memory. Allocates space for them and stores them. But when you actually use that word in a program, in another word I should say, when you actually run the word, it uses toFetch, which just pulls those values out of memory. Since we've already defined that, the same as if it was a variable. Now then, we also have toSortColor, which, given that the sortron colors don't use the same colors as the wire colors, this just converts between the wire colors to the sortron colors. So if it makes a copy of the value that's on the stack, in other words the wire color, then if it's greater than 2, orange is 1 and white is 1 and orange is 2 already, so those don't need to be changed. I believe that's right. So it creates a copy of it if they're greater than 2, takes a log base 2 of them to convert it to the metadata, and then adds 1 to it. Since the metadata starts at 0 and the color count starts at 1, we need to do that. Then it adds the 1 to it, and that's the end of that statement. So if we say blue for the wire color, that's going to be 2048. But for the Sortron color, it's 12. And that is its metadata plus 1. Now then, the sodium sulfide cell, sodium sulfide word, it's similar to the other one. I've just added a few things to make sure that the items are there. First, let's go over item slot. Okay, yeah, that's in 3. Okay, item slot is similar to item. It's based on item, but in addition to checking to see how much, well, this one checks to see how much of an item is and returns the amount. This one gives you the slot that a given amount of item is in. So the first slot that has at least this amount of the item in, it returns. If it can't find an item, it returns false here. If it can, it returns true here. So the same as this, it loops through all the slots. Again, it's the exact same till you get to right here, which is this line. And that takes the, if it has enough in here, this is what this is. It will get rid of the extra data. Then it's going to return the slot number and true. Then unloop and exit. These two kind of go together. If you're inside of a loop and you want to use exit, you have to use unloop first. And exit just terminates the word. It's kind of like a return statement in other programming languages. The other things are just cleaning up, like this does, to drop and drop, which is this drop. And this is the default return statement. If it can't find anything when it's in the loop, it'll return -1 and false. So slot -1 is kind of an error code, a standard error code, when you're looking for a positive value. Now then, let's move on to the constants. So now all of these are just 2 constants instead of 2 variables, which makes it easier to use inside of words since we don't have to type the extra parts. And I've also split the reactions words to a different disk. Oops, I should have done that. Let's try this again. Page should come first. Okay, so it's similar to how we did the first time. We have the for Sortron, the one that's connected to the sulfur stuff. That one. But unlike how we did last time, we actually check to see if there's any in there. So that's what this begin until is doing. Sulfur cell 1 item slot. So is there at least, or tell me what item slot is that there's at least one of these in there. And if that is true, if it returns true, actually let's go, if it returns false, it drops the extra -1 that's going to be there and waits 20 ticks. And then pushes another false on the statement onto the stack for this until. If it is true, pushes 1 onto the stack, swaps it, so for the sort pull it needs to be the item amount within the slot. So that's what this is doing. We only want to draw 1 out from the slot that this returns. So it's just swapping them for that sort pull. Then it pushes true on the stack. This true is for this until. So we're going to pretty much ignore it. It's just being pushed there for later. But then we do the same thing we did in the other word. We set 6, the sortron number 6, up to accept a sulfur cell and wait for sort match. Then we go to the 14 sort address, which is the one hooked up to the sodium cell up top there, the one by the liquid transposer, and it's going to wait for till we have at least one sodium cell. It does this by using the item question mark. 0 will evaluate to false, and any other amounts will evaluate to true. So if it has at least 1, it's going to evaluate to true, which will end the until statement. Then blue to sort color, set. So we're setting the sort color of sortron number 14 to blue. Then we're pulling 1 item out from the 4 slot, and we're setting up 5, sortron 5, to accept a sodium cell, one of them. We're setting the sort pattern up for a sodium cell and setting it to sort match 1 sodium cell. And that will make a set of sodium sulfide cells. Now then, one problem I've ran into is that the sodium sulfide is not a liquid, which is what I was expecting and had everything set up for. So I've had to change a few of my original plans, but I think we'll still be able to make this work. So the first thing is, or the next step, I should say, is we want to make the sodium persulfate. And to do that, we're going to have to do a number of steps. But first, we're going to be defining a new word. I've been having trouble with block 2 reverting to something else. I'm going to skip to block 4. Let's just do for list. So let's think about how we want to do this. The first thing is obviously we're going to make a set of these, since we need 2 of them exactly to make 1 set of sodium persulfate. That works out quite well for us. Then we also need 2 or 3 compressed air cells for every set. I believe that's right. I should probably check that just to be sure. Yes, 2 sodium sulfide and 3 compressed air. It also takes quite a bit of energy for this. So the first thing we'll do is we'll make it the considering if I want to go ahead and make it, or yeah, we'll make some NaS. So this is a big long thing. So we'll just call this word, oops, Big long work, but it'll work. Do I want to have this be in a loop that tells me how many I want? Actually, we'll just make it, we can put it in a loop in another word if we want to. So we'll just leave this to make one set at a time. So the first thing is to make an NAS. That's already taken care of, thankfully. Then the next thing is we want to check to see how much compressed air we have. So, that is what slot? Or what item thingy? That's 12 and this is 11. So first let's see if we already have some made. Rocks. Level. So just check to see if we already have any made. We do. That was 12. Sort address. Set that and then do 3. It's compressed air. Compressed air 3 item slot, and that'll give me the slot if it's possible, and if not, we'll have to go on to the next step. So if actually this should be inside of a loop. So begin. That's spelled wrong. Then this one should be the same thing. Now then, for PP, so if there is some, we'll go ahead and pull 3 out. And we'll set up what we could do is we'll just do it this way. That should give those time to flow through. So what should happen? But there's a couple things we need to worry about. First, we need to make sure we have enough space. But if there is 3 in there, then we can. Actually, this if should be. Oh, that's right. That 12 should be offset. If. Then it's a slot, so. Short pull. It should be colored. If, then we'll do blue to sort color. Sort color. Set. That's going to set 12 to blue. Now then, we need to figure out which one we're going to have except the items. Actually, first we can do hold on, let me actually do this off camera and I will be right back because this is taking too long. Okay, I am done typing, so let's go through what I've done. First, a couple of changes to the sodium sulfide one. I forgot to take into account the return value from sort pool, so I added a drop after each of those to get rid of that extra number. Then there was a semicolon here that shouldn't have been here, so I deleted that. And I think that's everything I've done. Now then, the first thing, I added a word for compressed air. So make compressed air and begin. It checks Sortron 12, or it switches to Sortron 12, sets the output color to blue, and Sortron 12 is the Sortron connected up here, which receives both the sodium sulfide and the compressed air, and the empty cell one is 11. Okay, so after switching to Sortron 12, it checks to see which slot has at least 3 compressed air in it. If there is a slot that has 3 compressed air in it, we messed up there. Yes. Let me fix this. I'll be right back. Okay. So we were here. We pull out 3 compressed air, drop the extra value, and the true for the until statement here. No, for the until statement here. Yes. That true is for that until statement. Then we set Sortron 7 to accept 3, or we set the pattern for Sortron 7 to compressed air. Then 3 sort match. So Sortron 7 is that one. Then after it has received its 3, or we'll go to the else statement, I guess. So if there isn't 3 compressed air in that chest, it needs to make some. So it gets rid of the extra slot return value from item slot. Then it switches to Sortron 11, which is the empty cells one. Sets that color to cyan, which is the color of the compressor. Then begin, waits a second, checks for empty cells. There should be a number there, so it should be that is 7. And that's line 10. So it should be 20 ticks empty cell 1 item slot. Okay, so where are we now? Here. Then if there is, actually that should be 3, crap. Okay, so if there is 3 empty cells, yes, that's what that's supposed to be. If there's 3 instead of 1, we just push true back on the stack, because if it's going to use up that true from the return statement of item slot. Else we drop the extra slot return value and push false on the stack. That false is for this. Is that true? But if there is 3 in there, it will break out of this loop and reach here, so we'll pull out 3 of them. Swap, sort pull, drop the extra value from the sort pull, switch to Sortron 13, which is this Sortron right here, the one that's connected up to the compressor. Are we now? Right, Sortron 13, empty cell sort pattern, then 3 sort match, then false for this until, waits 30 seconds, ends this if statement here with that then. It had to get things a little bit squished in right there to get it all to fit, but that's the end of that if statement, and then this begins. So if that was false, it goes back and then checks the chest again. And the delay is short enough that it tends to make more than one pass through the loop if there isn't any in there, so that it will have at least a couple sets of compressed air for when it needs it. Now then, for the sodium persulfate, let's fix that first though. Flash. And there. Okay, for the sodium persulfate, first we make the compressed air. Then we switch to Sortron 12, which is again the Sortron that's connected to the chest of sodium sulfide and compressed air. Set that to blue, which it is going to already be, but just making sure. Then begin. We check to see if there's at least 2 sodium sulfide cells anywhere. If there is, we pull out 2 of them, drop the extra value, and we set Sortron 8 up to receive 2 NAS cells with NAS sort pattern, 2 sort match. And the true is for this until statement. So we'll break out of the loop. Else we drop the extra return value from item slot. Push false onto the stack for this. Go to the NAS word and make a couple of sodium sulfide cells and wait 30 seconds after those are made. So let me load up this word again, and I will be right back to show you this working, I hope. Okay, so we've got a bit of delay, and then we're going to run the word. I've taken out all the stuff from that chest, so we'll get to see the entire process. So the first thing it's going to do is check here to see if there's anything in here, and when there isn't, it should check here for empty cells. Once it finds some, it's going to pull out 3 empty cells colored cyan. Those are going to go down into the compressor here. Let's see, they should be coming through in a second. Yeah, there they come. It's a bit slow because this has not been upgraded to the other types of tubes. I can't remember the name right now. That's a problem there, because now that has nowhere to go. But then those 3 will come back here. But this should probably run one more time and send some more compressed air cells out. I think, yeah. But there goes another set. And while that is running, the other compressed air that we've sent back should be coming up here soon. Yeah, there they go. By the time those get done, this should be ready. I just saw them. Here they come. Now then, in about a few seconds, they should be pushed out. Come on, whenever you're ready. "30 seconds delay," I think, is how long I put in it. Tick-tock. Well, whenever it wants to, it will. It's 30 seconds after that reached. Okay, there we go. There goes the 3 compressed air, and those are going to go down to in here. And again, we have a problem there because those don't have anywhere to go. But now this has 3 compressed air. Okay. So the next step is it checked for sodium sulfide and didn't find any in that chest, so it decided to make some of its own by putting 1 sulfur cell from here, then all the way up. There goes a blue colored sodium cell from this sortron, which is going to take its sweet time getting down. Okay, I think this floor. And yeah, all those things running through are going to be a little bit messy. But once that gets here, which is going to take a little bit, let me, well, here it comes. I think once we have enough of the copper, we might start upgrading some of this stuff, some of this tubing. But that hasn't reached here yet. Okay, it has. Now that's reacting. And just to keep that from making a whole nother set and us having to wait, I'll stick these in here. Go ahead and stick these in here as well. I wonder where those other ones went. I could fix that one problem with those by making it output these white. That would solve at least part of the problem. Would not solve the empty cells problem, but that shouldn't be a big deal, I think. Okay, but we should be having some sodium sulfide cells coming down soon. I think. Let's go check. We may still have a problem there. Sorter error. Okay, so we have a problem somewhere. Where was the sorter error? 8. We made it to here. I see what the problem is. We need to move this inside of this loop. And then it should work. And that should be everything. So I'm going to do that. And I guess I'll end the episode here. Actually, no, we're not done yet. We still have one more thing to do. So let me fix that. Make some sodium persulfate, and I will be right back. Okay, I've got that running. I fixed that one little problem. And you can see this is manufacturing. Now then we need to come over here to where the copper is being sent. Let's see. We need to put this here. Give it a cell. Then some redstone power. Color is red to match everything else. Now then we need to give it a little bit of power. See over here. Yes. So it's right there. Just put that there. And we should be good. Yep. There's lots of power in the lines right now. So it should start pulling it from above now. The same way the mercury is. Yeah. This is where it is being processed. Now then, I just need to get enough copper made to be able to make the liquid ducts for the tubes to get it to go into the sorting building. Liquid storage building, I mean. But yeah, I think that's going to be it for this episode. Next episode... Actually, let me see how much time we have left. Yes, it is going to be it. We're already running a bit long. So, like if you like, subscribe if you're not. Thanks for watching, and I will see you next time.